Hello and welcome. Today's lesson is about mastering exponential equations. Whether you are prepping for SAT, GCSE, or similar examination, we've got you covered. What is an exponential equation? Simple. An exponential equation is an equation where we have the variable in the exponent position. For example, we have 2 to the power x equals 16. The variable here is x, it is in the exponent. Alright? This is different from a linear equation such as 3x plus 2 is equal to x. This is a linear equation. Okay, as simple as that. So, why do we have to learn this? There are many real-life situations where we apply or use exponential equations. Think of compound interest in finance, radioactive decay, and even algorithms in computer science, where we sometimes have to measure the complexity of an algorithm. We use, in some cases, exponential equations. How do we solve these equations? There are various ways of solving these equations depending on the nature of the equation. Let's look at the first method here, where the bases are the same. Look at this example. 2 to the power x is equal to 5. The base here is 2 and the base here is 2. When you have the bases the same, like this, what you do is that you simply equate the exponents. So in this case, x is equal to 5. Simple. Similarly here, you have 2 to the power x or 3 to the power 2x equals 3 to the power x plus 1. The base here is 3 and also 3 here. Since the bases are the same, we equate the exponents. So we have 2x is equal to x plus 1. We subtract x from both sides, so x minus x is equal to x plus 1 minus x. And this gives us x is equal to 1. Okay. So, let's look at this other method. Here, we have the base 2 here and 8 here. We need to rewrite the bases. We need to rewrite 8 in a way that it has a base of 2, because we know 8 is the same as 2 times 2 times 2, which is equal to 8 to the power, which is equal to 2 to the power 3. And so we can write this equation as 2 to the power x is equal to 2 to the power 3. Now we go back to the case where the bases are the same, 2 and 2. So we equate the exponents. So we write x is equal to 3. Similarly here, we can see 27 and 9 have something in common. 27 and 9 are both powers of 3. So we can write 3 cubed, because 27 is 3 cubed, raised to the power x is equal to 3 squared. Now, when we have something like this, x to the power m raised to the power n, this is the same as x to the power m times n. So if we apply that to the left hand side here, we'll have that 3 to the power 3 times x, which is 3 raised to the power 3x, is equal to 3 squared. So we have the bases are the same, we equate the exponents. So we'll have that 3x is equal to 2. When we divide both sides by 3, we'll have that x is equal to, because 3 will cancel 3 here, so we have x is equal to 2 over 3. Okay, as simple as that. When you have a situation where you can rearrange the bases like this, you do it. All right, let's move on. Okay, let us look at the third method. Here we use logs. Okay, now look at this example. 5 to the power x equals 20. We cannot write 5 directly or 20 directly as a power of 5. So what we do here is we use logarithms. So what do? We take logs on both sides. So we write log. Here the log is to base 10. You can choose any base. I'm using base 10. Log 5 to the power x is equal to log 20. And when you have log a to the power b, this is the same as b log a. So when we apply that here, we have that x times log 5 is equal to log 20, and therefore x is equal to, divide both sides by log 5, is equal to log 20 over log 5. Okay, we have this other case here, this method 5, where we have method 4, where you have multiple terms. You see this? Okay, how do we do this? We can rewrite this as 2 to the power x plus 2 to the power x times 2 to the power 1 is equal to 48. Why am I writing this? Because if we have that x to the power m plus n is the same as x to the power m times x to the power n. So that's what I'm using here. Okay, so we can factor out 2 to the power x here. So we have 2 to the power x into 1 plus 2 equals 48. So 2 to the power x times 3, 3 is 1 plus 2 is 3, is equal to 48. We divide both sides by 3. 3 will cancel here, and well here we have 3 to 48 is 16. So we have that 2 to the power x is equal to 16. But we also know that 16 is equal to 2 to the power 4. So we have the same base here as here. So we equate the exponents. Therefore, x is equal to 4. Let's look at the final case here, where you have the base is a natural log. If we are dealing with natural logs, where we have base e, okay, usually written as ln, like that. When you write ln, that's the same as log to the base e. So in this case, when you have the base e, we take natural logs on both sides to have ln e to the power x is the same as ln 7. All the properties that you have in log to the base 10 also apply here. So here we have that x ln e is equal to ln 7. Now when you have a log a to the base a, this is the same as 1. So as I said, ln e here is the same as log e to the base e. So this is equal to 1. And so we have that this one is 1. So we have x times 1 is equal to ln 7. And so x is equal to ln 7. Here is your challenge. Pause and try this on your own. Answers are in the comments. To recap, when you have an exponential equation to solve, you check whether the bases are the same. If the bases are the same, you equate the exponents. If they are not, you see if you can rewrite the bases if possible. If not, you can use logs. If it is possible, you use logarithms on both sides, or you use the fold method, which is that of factoring if you have multiple terms. Of course, if the base is base e, you use the natural logarithm. Thank you for learning with Laureate Academy. Please subscribe, comment, and keep that math spirit high. Until next time, bye-bye.